Hi, I'm Miss Owens. We're going to be starting your unit on chemistry with Chem 1 describing matter. If you're following along in the lab notebook, this is on page 4. So we're going to be looking at the three subatomic particles and their charges and looking at how matter can change. So matter is anything that has mass and takes up space. Everything around you is made of matter. The table you're sitting at, the chair you're sitting on, the air that you're breathing, water, all things around us that have mass and takes up space are going to be considered matter. So chemistry is the study of matter, the study of the properties of matter and how matter changes. In this example, you can see that there are a lot of things represented, and all of these things are matter. The bowl, the spoon, the ingredients in the bowl, the recipe book, the styrofoam, eggs, the tin pan here that's going to be used to bake cupcakes. All of those things have mass and they all take up space, so they're considered matter. So atoms are small particles that make up elements. Atoms are going to be made of three subatomic particles: protons, neutrons, and electrons. You may have heard of those. Your stem sub means under, so literally subatomic is kind of less than, is below atomic particles, is below the atom. So within these subatomic particles, they have specific types of structure and specific locations for each one of those. So you have this little image here that is kind of the basic representation that we have of an atom. So a lot of people, when you think about atoms or you think about chemistry, you kind of bring this image to your mind. So this is one particular model. This is one particular representation, and we're going to be looking at a few others. So this is a Bohr model, B-O-H-R. So this is named after Niels Bohr, the scientist who developed this particular type of model. And this shows the locations of our three subatomic particles in kind of a very clear linear way. So our first subatomic particle is proton. We have neutrons, and our third one is my favorite, the electron. So our protons have a positive charge, and they're going to be found in the nucleus. So when we look at this particular model, this is our nucleus, our central core. So the protons in this model are the circles, the blue circles here, that have the plus sign. An easy way to remember that protons are positive is that proton and positive both start with P. And also your stem pro refers to positive. So both of those ways can help you remember that protons are positive. Our neutrons are going to be the subatomic particle that is neutral. It has no charge. And it also is going to be found in the nucleus, so it's in this central core. In this image, the neutrons are the red circle, so they do not have any kind of symbol in them because they don't have a charge. So the overall charge of the nucleus is going to be positive because the neutrons aren't carrying any charge. An easy way to remember that neutrons are neutral is the first part of the word neutral, neutra, which is the same thing as neutron, and also neutron, no charge, both start with N. Our last subatomic particle, electrons. So the electrons have a negative charge, and in our Bohr model image, these green circles with the minus sign, those are our electrons. So the electrons are not found in the nucleus. The electrons are located in the electron cloud, and they're organized in these orbital shells in this particular atomic model. So the electrons are going to spin around really fast, and they just move outside the exterior of the atom. So the atom's charge overall is pretty well balanced because you have the electrons that are negative on the outside, and then you have in the center in the nucleus the protons that are positive. So in this image, you can see the location of these specific subatomic particles. Protons are right here, our blue circles with a plus sign. Neutrons, red circles, no symbol in them. And electrons, the minus signs in these green circles. So our fancy little periodic table here, this is very important to chemistry, and it organizes a lot of information, and it helps scientists to be able to share information as well. So this is the periodic table of the elements. So elements are made of only one type of atom. So for example, the element gold is only made of gold atoms. The element oxygen is only made of oxygen atoms. So each one of these squares on the periodic table represents one particular element. So Fe, for example, kind of in the center here, Fe is the chemical symbol for the element iron. And all the information, all the numbers that you will find in that box are only going to be specifically relating to iron. So elements are pure substances. They cannot be broken down. They cannot be broken down into anything simpler. Molecules. This is another term. So molecules are two or more atoms that are joined together, that are bonded together. And this may be atoms of the same element, or it could be atoms of different elements. For example, H2O. H2O is the chemical formula for water. This is a picture of a water molecule, the chemical representation of a water molecule. So this probably looks familiar to a cartoon character you may be familiar with. Mickey Mouse, right? So in this Mickey Mouse water molecule, the O, this larger atom here, that's our oxygen, so that makes up the Mickey Mouse face. And then we have these two smaller Mickey Mouse ears. These are our hydrogen atoms. And those are smaller because hydrogen is the smallest element. So that's why they're represented in this picture smaller, whereas oxygen is a little bit larger. It's over here on the right-hand side of the periodic table with the nonmetals. So a molecule can also be two of the same atom bonded together, and when this occurs, this is called diatomic. Your stem di means the same thing as bi, so di and bi, it means two, right? So diatomic is literally two atoms. So a diatomic molecule is going to have two of the same atoms that are literally bonded together. They're joined together chemically. So oxygen, breathable oxygen, is O2, and it's a diatomic molecule. So let's recap and start from the smallest and move to the greatest and just kind of see how things are organized. So we have our subatomic particles, our protons, neutrons, and electrons. Those make up the structure of atoms. Atoms make up elements, and elements are pure substances that cannot be broken down. And our elements can be bonded together to make molecules. And we're going to talk about another word, compounds, in this unit as well. So elements, usually when you see the word atom, it's referring to a specific amount of that particular element that is represented. So when we're modeling molecules, we often see circles that are labeled differently or that have different colors. So it's important to remember that molecules, atoms, elements, all these things are invisible, right? So scientists have to use models to help show how they interact, to show how different elements interact. And so we're going to look at a couple of them together. So this is a water molecule. This is our Mickey Mouse shape that we just looked at a few minutes ago. So we have our two Mickey Mouse ears that are hydrogens, and we have our one oxygen. So this chemical formula is H2O. This is a water molecule. This is O2. This is breathable oxygen, diatomic oxygen. So in this example, we have two oxygen atoms that are bonded together. And we know that they're bonded together because in this image, those circles are literally touching. And you can see that they're kind of joined together here. So this is our two oxygen atoms that make up an oxygen molecule, a diatomic oxygen molecule. So our last example to look at is a carbon dioxide molecule. So carbon dioxide is CO2. Carbon dioxide is made of one carbon atom and two oxygen atoms. So the C in CO2 stands for one carbon, and O2 stands for the two atoms of oxygen that are present.